Hey guys, welcome back to our Form 5 weekly science lesson. Alright, let's continue from last week. If you still remember what we learned, okay, we learned about velocity and acceleration, okay, and then we use this ticker timer to measure velocity, okay, if you still remember them. And then the very important part here is 50 ticks per second, so each dot is 0.02 second. And remember, don't count the first dot, already mentioned to you, okay. And then the type of motion, okay, if I'm moving there, this is constant velocity, low velocity, moving very slow. This is, if it's very far apart, then it's high velocity, okay. And then can you see this is initial and then it's becoming faster, okay. So this is increasing velocity, or we call acceleration, and then this is deceleration. All right, so today we are going to learn how to calculate acceleration. Okay, we have learned how to count velocity, but how do we calculate acceleration in ticker timer? All right, very simple. Okay, so now can you see there are 4 strips here? Okay, there are 4 strips here. Okay, 4 strips here. So do you still remember our acceleration formula? Okay, acceleration is written here: final velocity minus initial velocity divided by time. Okay, so where's the final? Final is the last strip lah, and then this is the initial. Okay, so use what we have learned last week. Okay, how many dots here? Let's count. Remember, don't count the first dot. Don't count the first dot. Like I said, you tuition from 3 to 6, you don't count 3, 4, 5, 6. You count 4, 5, 6. You don't count the first hour. Alright, so 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Usually every 10 dots we cut into one strip. You want to make it 5 is fine, but normally it's 10. Okay, so each dot is 0.02. So 10 dots means times 10, which is 0.2 seconds. Means each strip is 0.2, 0.2, 0.2, 0.2, 0.2. Alright, very simple. And then let's look at the final velocity. What's final velocity here? Okay, what's the length here? Remember, what's the formula of velocity? Let me write here. Velocity is displacement or distance, means the length, divided by time. So what's the length here? The length is 12. So 12 divided by 0.2, because the whole thing is 0.2, you should get 60 cm per second. You might say, sir, I want to use meter. Can, no problem. Okay, and then for initial, how long is this? This is 6 cm. So 6 divided by 0.2, you get 30. Okay, so now I have my initial velocity, I have my final velocity. Here's the thing I want you to take note. You might say, what's the total time taken? Because I want the total time. A lot of students would do this: 0.2 plus 0.2 plus 0.2 plus 0.2. So the total time is 0.8. Correct? No. Why is the answer 0.6? Okay, when we count velocity, we don't count the first dot. When we count acceleration, we don't count the first strip. So the first strip is not included for time. Okay, if you want to calculate the total time, we don't count the first strip. So how many strips here? 1, 2, 3. 3 strips. Okay, 3 times 0.2 is 0.6. So please take note here, don't count the first strip. Okay, if not, your answer will be wrong. So 60 minus 30 divided by 0.6. So the acceleration of this graph is 50 cm per second square. Okay, remember the unit is 0 by -2. Alright, I hope this makes sense. Okay, final velocity and initial velocity shouldn't take you very hard to calculate. Okay, but just the time is a bit tricky here, so do take note. Alright, so let's look at the graph here. Okay, this is the similar as this one. Alright, so this is constant velocity, can you see? So no acceleration because the graph is flat. It's moving with constant speed all the time. This one increasing lah. Okay, acceleration. This one deceleration. This one accelerate then decelerate. Okay, simple concept. I hope this makes sense. Alright, this is a bit trickier than if you use a speed camera, but of course this we use manual way to calculate them. Okay, so we'll look at the exercise later. Okay, today I want to talk about inertia. Okay, inertia. Don't worry, no calculation here. This is a concept, so no calculation here. Okay, so what is inertia? Okay, this is the definition you need to know. Inertia is the tendency of an object to maintain its original position, whether stationary or in motion. Alright, so what does it mean? Stationary inertia is the tendency of an object to resist change in stationary. Motion is tendency to move against force. Okay, what does it mean? Okay, let's say now this is a bottle. I want to move it because this thing is rest, not moving. I want to move it. There's a resistance. He doesn't want to move. He doesn't want to move. Or when someone throws this bottle at me, if I want to stop this bottle doesn't want to stop. There's a resistance there. So this resistance from moving or the resistance from stopping is what we call inertia. Okay, so to put it short, a simple way I memorize is things at rest stay at rest. Okay, moving things stay moving. Okay, things at rest stay at rest. It doesn't want to move. Moving things stay moving. Okay, so the resistance, I want to resist, I don't want to change my motion, is what we call inertia. Okay, like I said just now, this is at rest. It want to remain at rest. I want to push it, there's a resistance. This thing is moving. I want to stop it, it wants to keep moving. So the resistance, there's a resistance. So these resistance, we call it inertia. Okay, very simple concept, inertia. Moving things will want to keep moving. Things at rest, they want to stay at rest. They don't want to move. Okay, so this is what we call inertia. All right, so like, can you see stationary inertia? When the car is moving, I'm moving as well. When I brake the car, now the car stops, my body wants to keep moving forward because I have the inertia. That's why when you brake the car immediately, you will just go forward because you have the inertia. Okay, and of course, motion inertia, when the bus, okay, when you stand in an LRT, when the LRT moves, you will, let's say the LRT moves this way, you will go backward. Why? Because when the LRT is at rest, you are at rest. When the LRT wants to move, you want to resist the movement, that's why you go backwards. Okay, this is what we call inertia. Okay, so can you see? Things at rest stays at rest. Moving things stay moving. Alright, so I hope this makes sense. Okay, inertia is affected by one factor, which is mass. Okay, mass. The heavier you are, the bigger your inertia is. That's why a car is easy to stop. A lorry is very hard to stop. Car is 1000 kg. Okay, mass is low, easy to stop. A lorry is 50,000 kg with full load. That's why it's very hard to stop. 50 times the weight, the mass, 50 times the inertia. That's why the brake should be 50 times stronger. Okay, so that's why it's called, that's what inertia is. So the bigger the mass, the bigger the inertia. All right, so what are the inertia examples here? I'm not sure what's the first. Yes, the chili sauce one. Okay, when you pour chili sauce out, what you do is you move your hand quickly, so the sauce will keep moving. So when you move your hand, the sauce will keep moving. And then when you stop your hand, the sauce wants to keep moving because moving things stay moving. So the sauce will keep moving. That's why the sauce will be splurted out from the bottle. Okay, this is inertia. And then when you pull a tissue, same thing. Okay, when you pull a tissue is at rest. It wants to stay at rest. The tissue box wants to stay at rest. So the tissue box is resting, and then you can pull the box out. Okay, so similarly to big ship and small ship. Okay, so big cruise ship like this, I think I've read somewhere before, half an hour or 1 hour before they emerge the port, they have to shut their engine. That's how big the inertia is. It takes them 1 hour to brake. So can you see how strong the inertia is? Okay, so if they shut down the engine 10 minutes before the port, they will langa all the way to the port already. Okay, so they cannot do this, so they have to brake very quickly. That's why bigger car or heavier vehicle, you need to brake very early. That's why please don't cut in front of a lorry unless you want to die, because they cannot react that quickly as a car. If suddenly a car cuts in front of your car, you just press on the brake. Yeah, you might have a mini heart attack. Okay, you might have a small accident, but if you cut in front of a seriously heavy 18-wheeler lorry, that's how you die. Okay, so please don't do that because the inertia is very big. All right, so what else is inertia? You shaking your umbrella. Yeah, right here. Shaking your umbrella is inertia. So when you turn your umbrella here, the water on it turns as well. So when you suddenly change direction, the water wants to keep moving that way, so the water will be shaken off. So inertia again, moving things stay moving. So what are the safety features in car? This one you need to know. Okay, you need to memorize this. Okay, only 3 examples here. So what are the safety features in car that uses inertia? Number 1, seat belts. So like I said, a car when it stops, you want to keep moving forward. That's why the seat belt is there to prevent you to moving forward. Okay, seat belt used to be what do you call that? We just tie it here. So the seat belt we use today is what we call a 3-point seat belt. Okay, who invented this? A Swedish company called Volvo. If you know what Volvo is, okay, they choose to share this design to everyone. That's why we are all using 3-point safety belt now. Okay, very amazing design. Next, headrest. Okay, so this is to prevent something called whiplash. Okay, you know what's whiplash? Okay, when your car is rear-ended from behind, okay, if your car seats used to be until shoulder, and then they noticed a problem in the 70s. Okay, in the 1970s, when car is rear-ended, okay, you do this. Okay, if there's no headrest, you will snap your neck, and that's how you die. Okay, there are many cases like this. Okay, I have a student who told me that his grandpa died because of the whiplash injury. Okay, because old cars, they don't have this headrest. So now this is a necessity. A car that doesn't have a headrest cannot be sold because it's dangerous. Okay, that's why you look at F1 drivers, they have a very big headrest. They wear a helmet. Okay, if you watch F1 or any motorsports, they wear a helmet and then they have a headrest attached to the helmet, a very big headrest. Okay, why? Your car, fastest speed you can go 100 something. F1 is 300 something. Okay, if you fail to stop, you will snap your neck in half. Okay, that's why they need a very big headrest. Okay, this is one of the safety features. Next, airbags. So you have seat belt to pull you backward, and if you are happen to thrown forward, the airbag is there to stop you from going forward. Okay, I wish to say that seat belts work together with airbags. If you don't wear your seat belt and airbag they deploy, you will die. Okay, because you are thrown forward and then the airbag will throw you backward. Okay, it's the change of this kinetic energy that can kill you. Okay, so wear your seat belt, kids. Okay, I'm sure nowadays modern cars, if you don't wear your seat belt, that thing will beep till your ears drop. Okay, because yeah, it's trying to care for you so that you don't die. Okay, it's a safety feature. All right, so airbags there. So your car should have at least 2 airbags. Okay, if you're driving a slightly newer car, okay, if you drive a very new car, you should have like 6 or at least 4, 6, 8. I've heard 12. Okay, good. In imported cars. All right, so seat belts, headrests, and airbags. Okay, those are to reduce your inertia because too heavy of an inertia, that's how they kill you. All right, so that's it for this week. Let's go into exercise. All right, we have finished the labeling last week. Okay, so I'm sorry you have to measure this. No choice. Okay, let's just assume this is 4.5 and 6. I don't know about this. Okay, this should be printed on a paper and measured using a ruler. Okay, but this is of course not according to scale lah. So let's assume this is like this. So find the velocity at section 4. So where is section 4? Section 4 should be here. So section 1, 2, 3, 4. Okay, so look at here. This is not 10 dots. This is 1, 2, 3, 4, 5. So don't count the first dot. So 1, 2, 3, 4, 5. Okay, so section 4. So 1, 2, 3, 4, 5. So 5 dots. Each dot is 0.02. This is already set. Don't ask me why. Okay, so 5 times 0.02, 0.1 second. So I got my time. Okay, so now I need my displacement or distance. So what's my displacement or distance for section 4? This is 6 cm. So what's the formula for velocity? Displacement divided by time. So you should get 60 cm per second. Or if you want to put 0.6 meter per second, same thing. Okay, up to you. Meter and cm is accepted. Okay, why do books they use cm? Because meter is a bit too big. The number will look very small. okay, 0.6. Okay, so draw it on a graph paper. If you can't draw this, I feel sad for you. You can't even draw a graph. Okay, so 1.5, 3, okay, 4.5. Okay, sorry, my graph is ugly as shit, but you can understand that's good enough. Okay, identify the type of motion. What is it doing? It is acceleration. Okay, accelerating. Okay, acceleration. Or you can say increasing velocity. Okay, please don't say increasing acceleration. There's no such thing. All right, so shows a bar constructed from strips of ticker tape. Okay, it has 10 ticks. Okay, so every toe is 10 ticks, so don't count the first dot. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So each is 0.2. Okay, because why? Because 10 times 0.02, each dot is 0.02, you get 0.2. Okay, so calculate the average velocity. So what is average velocity? This is physics stuff. They don't want, this is initial, this is final. Okay, they don't want initial or final, they want average. Okay, what is average? Average velocity is equal to total displacement, okay, divided by total time. This is very, very simple. So what's the total displacement? You add all these lah. 3 plus 4, 7, 7 plus 5, 12, 12 plus 6, 18, 18 plus 7, 25. Okay, so what's the total time? You don't need to use the acceleration I taught you just now. Don't count the first strip and all. No. How many strips here? 1, 2, 3, 4, 5. So 5 strips here. 5 times 0.2 is 1. So total average velocity 25 cm per second. Okay, of course this is the easiest way to score if they ask this. Alright, so initial and final velocity. So what's the initial? Okay, initial, I use the first strip. This is initial. Label it so that you don't get confused. So initial is 3 divided by 0.2. Okay, you should get 15 cm per second. Okay, how about final? How about final? Final is the last one. So 7 divided by 0.2, you should get 35. Okay, as you can see, they won't ask you straight away, oh, calculate the acceleration. They will ask you to count the initial first. Okay, normally it's like that. Initial first, initial velocity 1 mark, final velocity 1 mark, and then acceleration. So if you get one wrong, I'm sorry, everything will be wrong. Okay, so easiest way to score. Come on, how can you not score this? Okay, calculate the acceleration. So final minus initial. So what's my total time? Remember just now, don't count the first strip. So how many strips here? 1, 2, 3, 4. 4 strips. Each strip is 0.2. Okay, so 20 divided by 0.8. 0.8. It should be around 25. Okay, oh, 2. Alright, simple. Simple. Okay, one more. That's how you score 1 mark. Come on. Okay, so again, take a timer. Define velocity. Rate of change of displacement. Okay, or can say displacement over time. Displacement, not distance, because distance will form speed. Now I want velocity. Velocity is displacement. Remember what's the difference between displacement and distance? Distance is the curvy one. Displacement is straight line. Okay, define acceleration. This is the rate of change of velocity. Okay, or you can say velocity over time. Okay, determine initial and final velocity of the sphere. Okay, so how many dots here? Well, they didn't draw the first one. So 1, 2, 3, 4, 5. So 5 dots here. Okay, so since it's 5 dots, the time is 0 0.1, 0 0.1, 0 0.1, 0 0.1, 0 0.1. So this is initial strip and this is final. So what's my initial? Okay, initial equals to, what's the displacement? 10. Time is 0 0.1. I should get 100 cm per second. How about final? What's the length of final? Final length of final is 50 divided by 0 0.1. You should get 500 cm per second. You must say, oh, so the unit is so big. You want to put meter? Yeah, sure, why not? So acceleration, final minus initial. What's my total time? Again, don't count the first strip. How many strips here? 1, 2, 3, 4. So 4 strips. Each strip is 0.1. So 400 divided by 0.4. You should get 1000. Okay, so that's how you score. Quite simple if you ask me. Okay, number 3. Figure 6 shows two spheres of the same size. Both are made to swing at the same time with the same force. Okay, so of course this is heavy. This is inertia. So which sphere will stop swinging first? Wooden sphere. Okay, explain your answer. Because it is lighter. Okay, or don't say lighter lah. It has lower mass. Okay, hence, okay, therefore, it has lower, what's the word? Inertia. From the result, what inference can you make regarding mass and inertia? Okay, the lower the mass, okay, the lower the inertia. Okay, C. Give an operational definition. This is the thing. A lot of students are scared to see this word. What the hell is this? Okay, so do you know what's definition? Okay, let's say, what's the definition of inertia? Definition of inertia is the tendency of an object to remain in state of motion. Okay, so right here, inertia is, but they don't want normal definition. The one I mentioned just now is normal definition. They want operational. Okay, operational means you make the definition based on your observation. Okay, so what's the observation here? Time taken for the sphere to stop swinging, isn't it? Okay, so inertia is, okay, the time taken for the sphere to stop swinging. Okay, this is what I mean by operational definition. But anyway, if you really can't answer this question, normally this is 1 mark. If you're really a perfectionist, then go for it. But if you're not, then yeah, whatever. Okay, but I will answer it lah. Okay, it's based on your observation. It's not that hard, not as hard as you think. All right. So D, if a fast-moving car is suddenly stopped, what happens to the passenger? They are thrown forward. Okay, why? Because the passengers, okay, have inertia. Okay, so same concept here, one with sand, one with empty. So condition when it is moved, condition of can when it is moved. Okay, what does it mean? You can say requires large force. Okay, this one low force. So same thing here, condition of can when it is stopped, so take longer time. Okay, this one shorter time. Okay, I'm not sure what they mean by when they want a condition. Okay, give your inference. Okay, you can say P has higher mass. Okay, so more force is required to move it. Okay, takes longer time to stop. Okay, higher inertia. Okay, so you can just say high inertia would do. Give 2 examples of application based on relationship mass and inertia. Okay, so where do you do this? Okay, pouring sauce out of bottle. Okay, drying an umbrella. Okay, so H, explain how airbag and seatbelt can help save life during collision. Okay, so seat. Okay, first and foremost, they reduce inertia. Okay, so you can say seatbelt prevent passenger from being thrown forward. Okay, and then airbag prevent passenger Actually, both prevents it from throwing forward lah. Okay, I would say the same thing. Okay, so number one. Okay, tank and lorry should be divided into smaller tank or not divided based on principle inertia. I explain the answer. Okay, they should be divided. Okay, should be divided. Okay, why? Because when you divide the liquid, okay, they are smaller mass of liquid. Okay, instead of sloshing around like this, now you have 3 chambers, they are not combined together. So smaller mass of liquid, smaller inertia of lorry. Okay, easier to break. Okay, not BRE, okay, that is break, okay, to break the lorry. Okay, that's why inside a large tanker like this, they have compartments. Okay, so in case of emergency braking, they won't die, because this is considered high risk transportation, because it's fuel. Any fire, you are dead. Okay, so J, why a very long runway is required for the airplane landing? Oh, that's what they mean by the example just now. Okay, because airplane, okay, has high mass, okay, therefore high inertia. Okay, so it takes a long time for plane to stop. Okay, that's why the runway is very long. Okay, so it's not easy to fly a plane. That's why the inertia is very big, especially big planes like Air 380, Airbus A380. Okay, that's the biggest plane on Earth. Okay, so anyway, that's it for this week. So no calculation. I would say a very simple lesson week. Okay, I hope you learned something today. I hope this makes sense. I hope you can understand my lesson. All right. So next week we will go into a momentum. That's where a new formula will come in. But I swear it's very simple. Okay, almost the same concept as inertia. Okay. So till next week, I will see you again. Stay safe and bye bye.